Okie dokie, more fringe. I'm trying to rattle these ones out quickly, so I'm kind of doing them one on the back of the other. If you're coming into this cold, it might be best to go and watch the first one. Then you can unsubscribe and go and do something more useful. Still here? No, okay, all right. Next thing you probably want to do is go and look at Mr. Poole's videos, which I've linked below. I've also put some links to some other stuff that might be useful, but Poole's videos are worth looking at. So, what are we talking about here? So, RL Poole, his claims are all based on some assumed observations that Mr. Leedskalnin did using two of his megalithic structures at his coral castle in Florida. Those two structures are being the Polaris telescope and his analemic sundial. I don't know whether he called it an analemic sundial, but that's basically what it is. Now, I don't doubt that those observations are, or were, or could be 100% correct and 100% repeatable. We could all make those observations close to zero cost. It would be an interesting exercise to do so. What I am, and remain, at least for the moment, convinced of, is that Mr. Poole is wrong in the deductions he's made from those observations. Now, like I said, you probably want to go and look at Poole's videos to see what's going on. The first one is the one that Simon Dan got really wrong, and that's definitely linked below. So, first thing, we'll look at the claims regarding his Polaris telescope, and this is what Dan got wrong, twice. In short, the Polaris telescope is a bloody great chunk of coral with a hole in it. It's got some crosshairs within that hole. There's a viewing point some distance away, and if you line up your view through the crosshairs and the viewing point, you centre the points on the crosshairs, it points you pretty much exactly at true north. It can't be exact because true north does vary, but it's pretty good. It's a fairly cool viewing instrument. It's designed for looking at Polaris, and like Poole says, it's probably closer to a fixed in place sextant than a telescope. It's not enormously precise, but it's very repeatable. It's a good example of what the ancients could have done if you want to go down that line. They may well have done something like this. Now, Polaris is a circumpolar star. Poole mentions this in his video, and over the course of a night it goes round true north like that. And that is all within the field of view of the telescope. But short-term viewing is not what the telescope is apparently for. It's apparently for viewing the long-term movements of Polaris. If you view Polaris through the crosshairs at the same time every night, it will appear every night at a slightly different point around the crosshairs. If you were to plot those points and join them up, or I don't know, organise a camera that took a photo at the same time every night, you get an annual path, and that's what Poole says that the telescope is designed to observe. The path described by those observations is not perfectly circular, unlike the nighttime path. It's slightly elliptic, and it's elliptic enough that you can actually observe it using a big chunk of rock with a hole in it. Now, Poole's video, if you've watched it, there is a certain amount of ambiguity in it, and Dan kind of jumped right in on the wrong side of that, and said, so with his first video, he said, yeah, of course, Polaris revolves around the true north once a night.
Shut your fucking mouth!
So he got a fairly well-deserved slapdown from Poole on that, and so Dan then went and tried to get the upper hand, acknowledged his earlier error, which was okay, and then went on to explain that there would be an annual path as well as a nightly path. Well, yeah, that's what Poole was talking about. If you watched the video and listened to what he was saying, that's exactly what he was talking about.
Shut the fuck up, you cunt!
So another flat on the face for Dan, but who could have focused on what Poole was claiming about the path, because that's the bit that I reckon is geometrically wrong. Now, if you don't understand why that annual path exists, it's down to the disparity between the number of days in the year the number of axial rotations the Earth makes during the same time. And I've linked a video below that explains the concept in far more detail and far better than I can. But the upshot of it is that the Earth goes around the Sun once in 365 days, 365 and a bit, and while it's doing that, it actually rotates 366 and a bit times, which means that you've got a drift. It's a daily drift of slightly under 1 degree, and that gives you your annual path. It comes up to 90 degrees per season, as described by Poole, correctly but slightly ambiguously. And it, like I said earlier, it gives a slightly elliptic path, which Poole also notes, and totally correctly. And there you go. So that's all good. Now, I'm not going to get on to what Poole's claiming about that just yet. Next up, we've got the observations made with the sundial. This is probably down to me, but I failed to decipher exactly what Poole's saying about this, except it may have a fixed viewing position. It definitely has a peculiar geometry about its gnomon, and that's kind of it, really. Like the Polaris telescope, it's a very neat instrument, and Poole would have done very well to show some pictures of it, so I'm going to do that now. It helps to explain what's going on. So here's one where we can see what Poole is claiming is the seat that you're supposed to sit in to view it. Here's the gnomon itself, and you can see the curved projection or observation surface. And what you can see on that surface is that Leedskalnin has inscribed the solar analemma along the path of that surface, pretty much on an hour-by-hour basis. And so if you know the date, you can follow the shadow on the analemma path and get pretty much the exact time, I guess. Or you can go the other way. If you know the exact time, you can follow the shadow and find out what the date is, something like that. It's kind of neat. It is actually a very, very cool thing. So, where were we? There's a parallel between the two instruments. So one of them gives you observations, if you like, of the solar analemma, and the other allows you to observe the Polaris analemma, which is the path described by Polaris over a year at a given time. Poole doesn't explicitly state that, but it certainly seems to be critical to what he's talking about. Now, I'm not going to jump on Poole's description of the gnomon, because he describes it as 360 degrees, and I think it's probably just pretty down to being all excited because he thinks he's discovered something. But apart from that, it's all correct. We've got ways of observing the annual paths of Polaris and Sol at given times during the day. And this is where Mr. Poole takes a left turn at reality and heads straight off into Teletubby land. He's claiming that these observed paths give you orthogonal maps of the Earth's orbit. The path of Polaris, according to Poole, the Polaris analemma, shows the orbit of the Earth as viewed directly over the Earth's axis of rotation, and the analemma shows the Earth's orbit as viewed from the plane of the equator, or maybe from the plane of latitude of the observer, but side on anyway. That's wrong. It's all wrong. Let's look at the top-down path, for starters. Now, the eccentricity of that path is presumed by Mr. Poole to be down to the orbital motion of the Earth. So the eccentricity of the Earth gives you the Earth's orbit gives you the eccentricity of that path. Which basically means that the eccentricity is driven by a movement which is orthogonal to the Earth's axis. And you can consider that in 2 dimensions and construct a nice little right-angled triangle, and you can work out the lateral movement that's necessary to give a given angular deviation or eccentricity. So, take the actual orbit of the Earth and see how much angular deviation we should see just from the orbit of the Earth. So Polaris is about 300 light years away. and the Earth's orbital radius is about 8 light minutes. So you get a triangle which is about 1.2 thousand million units long on its long side, and on its short side is 1. So 1.2 thousand million that way, and 1. It's an issue of scale, and we'll come into issues of scale later. But so the angle, if you do the trig, the angle that's described is given by the arctan of 1 over 1.2 thousand million. Comes out about 2/10,000ths of an arc second, or well under a 10 millionth of a degree. Well, you're not going to be detecting that by looking through a rock. It doesn't work.
Oops.
Now, there are interesting reasons for the elliptic path of Polaris, but they're not what Poole claims. And it's a shame, because it would have been a worthwhile topic for a very interesting video, or even a paper in the field of, I don't know, archaeoastronomy or something like that. You know, what megalithic human civilizations could have known about astronomy, or something like that. If you tie it to Stonehenge and the pyramids, you get yourself a winner. You could probably write a book on it, publish it on Amazon. Still, onwards and sidewards. The side-on stuff, based on the analemma, the explanation that Poole gives in his video is really, really piss poor. I'm almost certain that he's making the same sort of geometrical error as for the overhead view, but then he kind of makes this enormously unexplained logical leap away from the observations made using the sundial and just goes straight onto the geometry of the gnomon, and he says that somehow the gnomon gives you the angle of it's bollocks as far as I can tell. It may not be absolute bollocks, I'll grant you that, but he fails to explain anything about it. His original hypothesis was that the corner-to-corner angle of the shape between the two corners of the dome, watch his video, is exactly 23.4 degrees, which is measured with a protractor, and that therefore shows that the Earth's orbit is at 23.4 degrees to the Sun's equator, and the Earth's axis is orthogonal to that plane, and then somehow the Earth moves axially with an annual frequency by the distance between the tropics, and he seems to have invented this movement because the analemma, I think, it's probably because the analemma is not a straight line, it's kind of a figure of 8 thing, and the solar analemma anyway. And this solar analemma is supposed to show a side-on view of our orbit, or maybe the shape of the gnomon or something. He's recently changed that view because of another angle that he's found between the corners of the gnomon that sort of kind of looks like the angle on a pinhole photo of the analemma that he's found somewhere, and that sort of kind of matches the angle of a line on Leedskalnin's rusty door, and that somehow means that the Earth is orbiting at 56.4 degrees to the solar equator, with the axis tilted at 23.4 degrees to the solar equator, and it's all utter shite. I am going to tear this new one. First of all, the analemma. He's got his head fixed on this on this photo of the analemma. However, the angle, which is what he's kind of focused on at the moment with this photo, depends entirely on what time of day you sample the analemma points. So, if you were to make a picture of the analemma, you choose a point during the day, and you take a photo every day over a year, and it plots the path. Or you could use a stick if you wanted, and mark where the top of the shadow is at a given point of day. Now, if you were to take a photo, pinhole camera photo, a time in the morning, the analemma will point to the east. Which way is east for you lot? That way. Point that way. If you do it at local noon, it's going to be vertical, and if it's in the afternoon, it's that way. Oh dear, the angle is completely arbitrary. So the angle of the analemma in the photo that he's chosen is also utterly arbitrary. It means absolutely nothing. It doesn't link to anything else. You completely forget that. Now, he's now saying that the analemma is somehow a map of our orbit, viewed from the side. Now it's affected by our orbit, but it's actually nothing like a map of it. It's all very, very well explained on analemma.com. It's just absolute bullshit. And then there's the shape of the gnomon. I'm very tempted to say that it's apophenia. That it's, he's finding a link between that and the thing that he's decided is Leedskalnin's discovery. I can't see any reason why it could be anything else, but then I failed to find any reasoning at all in the sundial part of his video. I can make an equally good hypothesis that the chair-shaped gnomon visually mirrors the viewing chair of his sundial, or perhaps vice versa. Who knows? Yeah, I think the latest changes to his gnomon theory are very much grasping at straws and still produce an answer which is utterly wrong. But we'll actually look at what he's doing with his discovery in the next video. We'll talk about his actual discovery. So, maybe later.